Hi everyone, welcome to part 4 and Artist Masterclass number 30, where we're going to be covering the final bits and pieces of our non-photorealistic rendering. So last week, I'm just going to tab straight over to the project. So last week we was just finishing up on getting this tree to work, and there was a couple of reasons why that tree didn't quite work as we had initially started to do, and we've got to get the alpha transparency, or at least the cutout, in place here. I'm going to go with cutouts versus transparency because it fits more with the cartoony look that we've been building towards. However, the actual modifications we need to do to get this work are actually pretty straightforward. So I'm just going to go ahead and do that, and then we should be able to jump onto the more important of the two topics I'm going to cover today. And the second one is writing your own custom image effects. Now this is an extremely powerful technique, so we can go into a lot more details in that as we get to it, but I'd just like to get the foliage shader done, and then we'll jump over to that. Okay, so I'm just going to edit my shader, which I've already got ready. Now, the first mistake I made last week was that I used the word cutoff here instead of alpha test, so I just put alpha test in there. And the second thing I needed to do to get this to work was I needed to change the queue. So we need to look up the Unity alpha test render queue. And just need to get the specific code for the shader. I think it's just Q, but I'll just double check that one. I think I've looked this one up over the course of my career maybe 500 times. Okay, there we go. That's the one we need. So I'm just going to add that to the tags. I think it's, yeah. So I've got that. Okay. So those two changes, and we tab back to our project. The other thing I've done just in the meantime between things is I've updated this project to editor pack 13.17, and as you can see, it's now working. And the reason I did that update was because we've changed some things that enable some new features that will be relevant when we come to the image effects part of the second part of this tutorial. Okay, so that's loaded. We've got our foliage kind of there. We've also should have a new cutout, so we can control the density of where the cutout is. Okay, that's good to have. Now, I guess I must use two. Interesting. Okay. Let's change this one to the tree shader as well, I guess, and just play with the cutout. Huh. Ah, I see. Interesting. Okay, so it's actually got a mesh, and then they've added to the mesh with the outlines. That's good, except it's going to complicate our work a little bit. So we might need to edit the line map for this one, but let's have a look. We'll add the alpha tint to this. Is that the same map? It is indeed. So I'll just pull this one open in Photoshop. So we've been working this before. While Photoshop opens the background, I just might tweak this a little bit so we don't get something quite so unattractive. We might need to modify our shader too, or make a third shader, which is just a quick one. Okay. So I'm just going to make these a little bit more natural looking leaves. And there is some shadowing going on here, as we can see. Okay, so that's the second problem we've got here. And you'll see it immediately as we darken this down. Our shadows are square. So the other thing that we need to do just in modifying our cutout shader, and this is continuing from last week, so I apologize if you're a little bit lost, we need to add a shadow pass to it. So we just do an add shadows pass, and that will cause Unity to write its own little shadow pass using our cutout. And with some luck, the shadows will look a bit more natural. But we're not lucky. My solution to this one might be just simply to disable shadows, but no shadows. So add shadow. Sorry, I'm not sure if this is plural or not. Unity is not consistent on that. Yes. So no plural on that, but other than that, that fixes our shadows, so now each leaf will cast an individual shadow that matches the rest of our shader. So what I need to do is I need to break up this object, because unfortunately it's been built with the tree element on the top there, and that's not quite the same as the model. In fact, it may even be easier just to make a quick modification of this and split this into two objects. That might be the way I go. So I'm just going to open this one up with Blender. I should have installed on here. And that was called Trio 1. Just delete that. Trio 1. Okay. Right, so we've really got two things here, and hopefully I can extract this all out. It's a bit of a hairy mess, quite literally. So I might just trying to think of the easiest way to get through to this, because this is going to be quite messy. These guys. So I might split this into three models, or two models actually. What I need to get rid of is this section. Gee, no. Right, so we can see here, so I want to select similar. Select connected. There we go. So the L key in Blender selects all the connected vertices. So this is the object that I actually want to break out. So I'm going to extract this, separate by selection, and now I've got a nice separate model with its own materials that we can use. And in fact, on that one, this is our separated blob. I'm just going to delete the second material. And I'm just going to rename that to something else so Unity doesn't try and auto map it to another one. Right. So I've got U separated out. And I'll just save that one out as a separate object, and then I will save our first tree. In fact, because those already are now separated trees, I'll just grab them both. I'll export them both as a selection. Okay, right, back to our, I'm just going to save this in our non-photorealistic folder too. Just find out where it is. This is the project folder we've been using so far. Right. NPR modify. Now, normally I'd hope you wouldn't have to do this, but because we have had to. Just for reference, I've made a preset in Blender for exporting FBXs that work with Unity. This is what I found generally works. FBX 7.4 binary, just save the main elements. You can just save the geometries only. In fact, today that might be what we'd want to do. Oh no, I'll save it all that. We've got Z forward, Y up, that's Unity's own thing, scale at 1. and I usually find ticking the apply transform on the mesh helps get things all consistently laid out when it comes into Unity. Okay, so I saved my thing. We'll just patch it up to use the same materials, and this way we can get this looking right. Okay. Okay, there's our modified tree. We'll just find our modified tree texture. So this is texture 01. And that is tree 01 no alpha. Hoping that included my big round bushy part. It might not have. Did it get exported? In fact, I've just done something really stupid, so I'm just going to quickly delete and redo this very, very, very quickly. There was a far easier way of doing this that someone probably has yelled at me about. So just import, same process, trio 1, import. I should have done this the first way. I'm just going to select that, select the select connected items, which is the L key. I'm just going to add a new material. I'm going to assign it. And we'll call this one tree 1B. Okay, we've got that. We'll just export this polysurface back out. Our modified tree, again, we'll just go to our Unity settings, export FBX, and hope that comes in okay. Now it should have 3 materials, which means we can reuse one without actually having to do a second mesh. Hey, okay, great. So we just need our trio 1. Yep, great, that's there. Fantastic, okay. Trio 1B. Should admit conflicts with an existing thing on there, but that's all we got. Okay, and trio 1B, I'm just going to go back to the standard tree shader. Sorry, standard shader. Right, with you, we're going to go. Right, so that's our first bit, and then I'm just going to change the trunk colors. I wonder why that's not... Right, we've got some lights in here that are affecting this object. Just move it a little bit out of the way. Okay, that's the first basics of our tree shader. It is a little bit ugly, just mainly because of color choices. Some more natural tones here should fix things up. So let's grab that and I'll push it a little bit towards the greens. Okay. So here from these two. And the last thing we'll do is we'll just change the line colors in this one. Like before, we've just been darkening these a little bit. Just pull these in. Right, basics of our foliage shader. Looks pretty straightforward. The only other thing we're going to do in addition to this is just add some simple vertex animation to it. So the fastest way to do that is just we're going to tick on animated materials here. So it's just this icon here on the edge. Click animated materials, and that'll let us just preview these materials. Just be aware that this will keep your graphics card spinning, so it might heat up if you're doing it for quite a while, same as if you're running a game. Okay, we should have a custom Vertex Shader in here. I believe we made one already. Yes, we did. Okay, so what we can do is we can manipulate the what's called the vertex position, and I think, if I'm correct, is it v.vertex? Just want to double check app data full. If we've declared our own here. No, we're not. So we'll just look up the definition of this app data full, which is a built-in Unity one. And that will actually contain the various bits and pieces. And I believe we can manipulate this one straight up. So we'll just look for dot position. So we'll just search for app data full. It's got position, tangent, normal, and 4 texture coordinates attached to it. So we can find that just by going v.position. If we do plus equals v.position plus float 3010. If we do that, and look at our thing, it should jump sideways, or up actually, because we're manipulating the y-axis. We might have some issues with our shadow pass through, or it's gone somewhere. Can't quite tell you where. To 0.1. Okay, so I'm going to add just a couple of variables to this so we can play with this directly. So I'm just going to add a vector, a float, which is just going to define our tree wave animation. So we'll call it wave strength, and we'll do wave amplitude as well. Okay, and we just need to declare these as floats somewhere in here. Did I modify those? Yes, wave strength and wave amplitude. Just find where I've declared all the other ones. Note, here we go. I'm just going to this way, so we can just have a quick look what's going on, because I'm not quite sure why it's turned white, but I'm sure there will be a reason for it that we will very quickly find. Right, so we've got wave strength and amplitude. It's a question why that's still running that one. Actually, should be on the other shader. Editing the wrong thing. Okay, here we go. We've got wave strength and amplitude, so we've set that down to 0. Is that one in use? This is also why Visual Shader editors are really nice to work with, because they save you from a lot of the nonsense. Okay, so we definitely know that modifying the position is causing that. We might be overriding this with something else. What I'll do is I'll just make sure that the position is being outputted. So I might just play with this and see if it has an impact. I don't think it should. I think editing the V there should be the one that we want to, but I'll just go O dot don't think this can be done, but let's just see. 0. Right, so just it's just a matter of editing this at all causing the problems. Indeed it is. Oh, right. File error. Should have spotted that to begin with. Okay. Maybe it's .pos. So we know what our issue is now. I'll just have a look and see if we have declared a custom one of this. No, we have not, so it should be just .pos. v.vertex, sorry, my fault. Okay, now we know what the problem is. Should be an easy fix. Should have read the manual. Okay. And this, with some luck. Right, so it's using a, we'll set the XYZ. And the reason for this is the vertex position being stored as a float 4 here, which means it's got 4 position properties. Not quite sure what Unity's using for the last one, maybe scale. But there we go. Okay, so we've got the basics there, and now we should have a little slider that we can go on one of these. Yes, we can now move our vertices around from within the shader without actually changing the model. And we're going to use this property combined with a sine wave and the time property in order to animate what's going on. So what we're going to do is we're going to make an amplitude based on the, we'll use the X position for this. And that means we'll go to back to front movement on how this works. We could use the world X position, but we'll have to do a bit of transformation in order to do that, and it might be a bit more work than we want to go into today. So to start with this, what we're going to do is we're going to modify the position by a sine of the time waves, of the time property. So we're going to do time.z. The time property is documented in the Unity wiki, but z I think is 1. That is 1 scale time. So if I do this, we should get something that's going to drift back and forward. Potentially very slowly. Right. Okay. So now we've got some basic movement back and forward on our tree. Not enough, but enough to give it a little bit of movement. And I'm not sure how good that's coming in through on YouTube, so I'll just zoom in a bit closer and wait. So, making this a little bit more realistic, we might add part of the, because you can see this going back and forward very uniformly. What we'll do is we'll just modify the position to also factor in, because we've got a sine wave, it'll repeat. We go v.vertex.x. And now we should see a wave drift through it. So you can see it's now drifting somewhat less evenly. And this is probably good enough to go, but we'll just make one final modification to this, and then we'll jump into the real meat of today, which is going to be custom image effects. So I'll just try that by the wave amplitude, which I know is not quite correct. It should be more period, but that's what I named them. We can use that to just control the frequency. So we can make this frequency quite high. It'll jitter around a lot. So depending on the strength of your wind. There we go. Now I've got our basic comic tree using shaders that we built ourselves in a non-photorealistic environment. And we can then take this however you want. But I think for today, this is probably going to be where we're going to leave the basic shaders. And I'll release all these shaders later today, probably in a couple of minutes after I finish this thing between when I finish and when my office hours start. But the next part today is going to be building a custom image effect. Now, I've already done a quick script that we'll review in a second that covers the basics of how to do this. And I'll walk through that in a moment. But today I'm just going to make a new folder for this. And the folder is going to be npr image effect. And this is a little bit complicated, and I have not done this before. So if there's a problem, I apologize. I've done this plenty of times in previous things, but this is going to be going into a couple of things I haven't touched for a long time. So I'm going to create a new shader, and I'm going to create an image effect shader. And that means it's just going to populate out with a few things that we're going to need. So we're going to create the image effect shader, and it's going to be, we'll call this our Sobel filter. Now, a Sobel filter, for those who are not graphics nerds, is basically a difference, and what it does is it brightens or darkens based on the differences of the surrounding pixels. In layman's terms, it basically creates outlines of a whatever input you want to put into it. So you can create sort of sharp edges and things using Sobel filters. If you used Photoshop, the Solarize filter is a Sobel filter, and there's others around as well. But this is going to be the basics of what we're going to do. We're going to need to create first that shader. Second thing we need to do is create a material for it. In fact, we may be able to, well, we'll see. So we'll call this Sobel. And the last thing we're going to need to do is make an image effect, just for previewing. We can do this through Lua as well, which is what we'll get to. I've got my little Lua script here, which is our camera overscribe script. It's very simple. It's actually simpler than the C# script is going to be that we can use for previewing. But the advantage of the C# one is that we can preview without having to hit play mode. So that's what we're going to do. We're just going to call this our Sobel. I'm just going to pull apart an existing image effect and use that as the basis of our thingy. So to create this, I'm just going to copy and paste from an existing source. We'll just need to close and reopen Visual Studio to get my Silver Complete working. So let's give that a second. So there's several parts to doing a custom post effect. The first is the shader, and that's what actually runs and produces your output. Similar to what we've been doing producing shaders for objects, an image effect is a shader that runs on the camera instead. So it runs across sort of after all the rendering has been completed and lets you modify the results. So often you use this for creating things like recoloring and tinting. Anything in the post stack is built with these image effect shaders. And that means that you can create your own effects here. So if you're an advanced developer, you can start creating your own things, like maybe you want to do robotic vision or something that requires a healthy amount of modification off the default post stack. You can use this technique to do that. So the second thing, I'm just going to hunt around for a basic image effect. Doesn't really matter which one. Hopefully there's one already in the editor pack. No, there is not. Okay, I'm just going to need to Google for a quick Unity sample image effect. And I'm hoping that the Unity documentation is going to cover this one. It's a slightly more legacy thing, but there should be still documentation. No, there's no sample there. Okay, right, this is what we need. So we need the image effect for the camera. Okay, right, I've got my thing. We've called this Sobel filter, or Sobel image effect. Just going to paste the guts of this in. Attach the bits we need. Right. Now there's some bits we want to pay attention to here, because it actually has a mirror in the Lua thing. The key thing is that we've got these two events. We've got the on-render image, which is when the camera has finished rendering, it does something called a blit. And a blit is basically just copying the pixels. In this case, it copies it through a material, and that material is the one that contains the shader that will actually render the image effect. So I'm just going to add this one to our camera in the scene that we've been previewing with, which is here. That's where I've got a post stack attached to it. The good thing is the Lua script actually gives you a few more commands over the built-in image effects thing. It's more closely mirrors the command buffer API that Unity have produced. I'm just going to wait a moment. Let's all compile, and then we're going to add our Sobel filter. I can find it, should be in here somewhere. And foolishly, I forgot to do. Oh no, I did inherit from it. Okay. Okay. Hold on, I need to rename this object to Sobel image effect. My fault for using spaces in file names. We also need to close and reopen Unity again. Sorry, Visual Studio. Okay. Right, so our camera, we should be able to just drop this in. Yes, great. We've got our Sobel image effect. Now, this is not going to do much, but we will be able to edit it, do something. Okay, so this we actually are not going to edit at all. This is just simply our image effect. I'm just going to drag the material on, which is our Sobel material. Our Sobel material is going to want our Sobel filter, which should appear under custom. Maybe not. What's it been labeled as? Right, so I'll just edit this guy too. It's not going to be hidden anymore. It's just going to be custom, just so we can create a material with it. Right, custom Sobel filter. Hooray! Okay, so I got a Sobel image effect, a Sobel material, that's on there. Okay, that's probably not going to do much until we start editing the actual shader. And this shader is going to be the same whether we're using Lua or whatever else. So we've got our Sobel filter shader, and that's just set to invert the colors. So we just need to do a quick pass on why this isn't displaying. It might be that we just need to add and remove the Sobel effect. And slot the Sobel material in, and turn that on. Make sure we're approving image effects. Aha. Okay. So we've got our thing, it's just inverting the colors. I'm just going to set this up to the camera position here, and we're going to be able to preview away this way. Okay. So as you can see, this one, it just simply inverts the colors, but we're actually not going to want to do this. We're going to use the Sobel filter, and we're going to actually multiply two things together. So a Sobel filter is based on, if we grab, in fact, I might pull up in Photoshop for this this demo. Just going to make a quick diagram of exactly how this works internally, in case you do want to do something similar yourselves. Sorry, this is all lagging up a bit much, a bit more than I'd like it to. Okay, so a shader, as you may or may not be aware from previous things, is a small program that returns the color value of a single pixel. Now, what we do with the Sobel filter is that we ask the system for the existing rendered image, and we can, from that rendered image, we can ask about neighboring pixels that have already been rendered in a previous pass. So a Sobel filter looks, say, at here, here. Come on, Photoshop. Don't lag quite so much today. Oh, come on. Might be doing too much at once. Continuous lag. I'm going to switch to MS Paint. Which in hindsight might be considerably faster. Right, so our Sobel filter, thank you Photoshop, basically if we consider this as our pixel, right, and we've got a bunch of pixels neighboring, very sketchy drawing. But the key one to care about is this one. The Sobel filter is going to look at this pixel, it's going to look at this pixel, this pixel, this pixel. It might also look at these ones. We can make these optional, but you've got basically the 8 surrounding cells that are attached to it. And then what we do is we look at the differences between these values, and if we sum the differences of the values, and if they're greater than a threshold, then what we're going to do is we're going to render this as black or white. Now, what we choose to actually pick this up from, we can do it a couple of ways. We can look at the color buffer, and I've grabbed a Unity Sobel filter. I found one online. Unity 3D Sobel shader. So I filter shader about 20 minutes ago, and this one looks like it'll do the job. So as you can see here, it's just looking at offsets and then rendering the result. So we're going to do the same. We can add these properties in to our shader. So I'm also going to add these functions. And we'll just add these delta x and delta y. This will be useful. We'll probably have to add a few more properties to this. Right, and then we're just going to do a Sobel filter off the input. So what we'll do is do the color instead of being fixed for color. We'll multiply that by the Sobel filter. So we'll do Sobel main text. The main text is the existing rendered image, just for reference. I.uv, and we won't invert the colors. We'll just return that because we're now multiplying them. We should see some fairly dramatic effects. Right, there we go. We've got something. As you can see, as we split this apart, we get more dramatic effects. So if you've used the Solarize filter in Photoshop, you will know exactly what you were looking at. But let's just make this a little bit more black and white. So we're aiming for a line art effect. So we're just going to use the saturate effect. That's going to mean it's going to keep to the 0 to 1 range, which is important because I have a feeling this is going into negatives. Apparently it wasn't. Okay, and we'll just pay attention to, we've got that. Let's do 1 minus. Let's see how that looks. And by 1 minus, we'll just flip this around. I'm not sure this is having much of an effect. Oh, yep, there we go. So we've got our outlines, as you can see. It's not quite perfect, but this is the guts of what we're trying to do. But I wonder if I take the post stack off, whether we'll see. Just not seeing the image effects previewing in the editor for some reason. Don't know why that is, but at least we can see them in game view here. Okay, so we've got our Sobel material, we've got our basics here. Now, we're looking at the moment at colors. So if we see what the Sobel filter operates on, it's on the color map. But what we're going to want to do is actually look instead at the depth map. So we're going to make a shader that reads the depth map of Unity. So we're going to go Unity 3D depth map shader. I had one a minute ago. Rendering depth, and that sounds like what we're looking for. I think Unity output depth is the thing we want. Hunt around a little bit here. We've used these a minute ago. Not a minute ago, we actually used this in our other shader, so I might even look at that one, because it does already have the thing we need. Let's see here. We have compute high depth, which I think is in our Vertex Shader. So Sobel filter shader, and we should have a app data V. So we got a V to F, which is what transfers from the Vertex program to the fragment program, which again, if we go back to the first lesson in this series, the Vertex program runs per vertex, the fragment program runs per pixel. So we're just going to add this. We're going to add a float. It's going to be our depth. Might need to assign a thing for it, but right, that should compute the depth. Just make sure this still compiles. No, it does not. What if I... Nearly have done something. So I actually need to do something with the compute iDepth. I'm just going to quickly Google this because I know there's a wiki page on this that's useful. Right, I'll just put it into text chord 1. Exclude DirectX 11 because I think that's the cause of our problem. There we go. Okay, so we've got our depth stored there, and we should be able to visualize that depth a little bit. So if I multiply, this probably won't be very useful, but we can. If I multiply this by the i.depth, yes, we won't see anything particularly close up, but we can zoom in a bit. So if I zoom really close to something, we should be able to, maybe that's not even useful, times iDepth. Interesting. Right, so we just need to, where's the projection parameters coming from here? They weren't linear iDepth actually. That's something I think we've got wrong. Why are we doing that there? So I just want to try and find a working example we can work from, because what we're going to do is we're going to apply that Sobel filter to the depth instead of based on the color changes, and from that we can determine sharp changes in depth instead of having to rely on sharp changes in color, which means our outlines will be more accurate. But I do need to find where this is hiding. To double check, so I'm just going to poke this in the shader a little bit. I'm just going to return the, instead of returning the color, I'm going to return the depth. 4 in fact. I might just scale that up a bit. I think it's linear iDepth, so that's the thing I want. Just find a quick example. Is this what we're looking for? Looks like it is. Right. We'll have to Pardon me messing around with this a little bit. Hopefully that gives us what we're looking for. I declared the file. Right, I need to declare that one. Right. This property here, this camera depth texture, that's filled in by Unity itself. Yaha! Hey, there we go. Okay, that works better. So as the camera moves around the scene, as you can see, we've just got the depth, and we're going to look a bit further. In fact, maybe we won't. We'll just divide that times that by 15, so that'll give us a little bit of a further view into the scene. So you can start to see that you could create some pretty powerful image effects here. If you wanted to make something look like sonar vision, for example, I'll make this divide by 15. Or something similar, this would be a great way to go, because again, what we can do is we can play with the animation. In fact, I might just quickly do a side tour through there because it is a cool effect. What we could do is something like this. So I've just changed this to, I'll do that plus 1. I'll set this between a 0 and a 1 range. I went 2. Okay, so now we've got this based on a sine wave, but that's not going to say much. What we'll do is we'll just add the time property. Now we just need to break this into 2 views so we can actually see it. Because unfortunately it's not going to update this immediately, but as you can see, I'm jiggling through here. The shader is rotating through the potential values based on the time, which will give you the wonderful ability to make things like radars and things that sort of sweep through the texture. Still, this is a pretty cool effect that you can play with. Next bit, we just wanted to put this to our Sobel filter. So what I'm going to do is I'm going to make the Sobel filter, instead of this thing, I'm going to create a new version, which is going to be Sobel depth. And instead of taking the text thing, we're just going to do that. And for this, we're going to sample. Change these to all to here. So instead of doing the text 2D lookup, we're just going to do the sample depth texture. We'll sample this quite a few times. This will become just a plain float. That should be right. No, that's going to be a sampler 2D text. Now instead of this, we'll just take all that out. We'll change our main text for that. And that, with some luck, should create our Sobel filter based on the depth distance instead. Just pull that one back up so we've got a bigger view. Now I'm not seeing that quite so exaggerated, so what I might do is I might just add a scale to this so we can manipulate. So I'll just add a Sobel scale. I'm just going to add that to our floats here. And then finally, we'll just multiply this result. Oh wait, that should be in Sobel depth. Still, we've added the scale anyway, so I'll just add that to the... Right. Okay, look at the material. We should be able to play with this multiplier. And now you can see we've got outlines based on distance instead of color. which means that only these sort of edges of objects are handled. So as we move this camera around, now we've got our comic outlines. Now, there's a few things we want to probably fix about this shader. One is that, as you can see, the outline is probably particularly get close. It's not really sort of 1 pixel thick, and that's because of these sort of f-width values. We had ran into this before in the NPR outline shader, and I think we fixed that through. I can't remember exactly which one we used to fix this. Which particular modification was in here that we got to work. Also, it's the f-width, so I'll just double check this one. I believe f-width should be the fragment width. I believe takes 1, yep. Let's just see what that looks like. So in our Sobel filter, we're just going to change this offset. So you can see there's that delta whatever. We're going to pull this out of here. We might make them a multiply. So we'll just do delta x and delta y. Delta x. That's what I'll do is I'll put this into the sort of depth and make this a bit cleaner. So it'll be times f width 1. I think that's right. If we got that right, the pixel should change around. It might be. Is it fragment height? Is there an F height? No, there's not. That's interesting. We didn't quite do what we want. I think we had it right. Seem to have lost this completely, in fact. All right, we'll take that out. We'll just shrink the numbers a little bit until it looks natural. We might need to do. You might want to do some investigation here on just how to keep that width a nice constant value. But the last thing we want to do is we want to add a scale to this. Whoops. That doesn't seem to work better with the difference between the x and the y. That might be due to the camera width. So there will be some divisions and things you want to play with there just to get that looking right. Nonetheless, I think we've got the basics there of what we want in our outlines shader, and as you can see, we've now got outlines attached to all of our buildings. So again, this is also all about building that comic feel. So looking at this, other than the awful color choices I've assigned to certain objects, this one in particular is not going to win any architectural design awards. But as you can see, we've now got if we switch over to the game tab, we've got our outline filters, we've got our depth color shading, our PBR comic shader. last thing we want to do, just in the last 5 minutes, is how to rig this up. So, I've already pre-written a script for you. You can use this in one of our preview viewers or editor pack 17. The key to our camera override script is this. So I'll just set up a game object, doesn't really matter which one, just create an empty one, and this is our custom image effect loader. And we're going to attach a script runtime. I'm just going to attach this script, camera override script, which is this little file here, to this, and this is pretty much good to go. So what we can see, I'll just put wait for player on it, but otherwise this is good. So we just need to add a resource to this, and a resource is a thing that a script can access, a Unity object of some sort that's just sort of piped into the script like a properties. There's a new version of this coming along that's actually far better and easier to use, but this one works now. We just name this image effect. And then from that, we just need to work in this material. So to give you a rundown of what the script does, first line is we grab that material that we just had as a resource. We copy it to a variable as a material. So we're saying this is a material, not an object or a sound or something else. The next thing we need to do is create a command buffer. Now, a command buffer is a sequence of commands that run on the camera every single frame. So they can be set to a whole bunch of different locations and events. We've got the add command buffer to camera. So the command buffer is this sort of string of commands. It doesn't actually need to be updated by the script every frame. It's just something, it tells the camera do this every time it renders. And the good thing here, reason why we've exposed this to Lua is that it doesn't require Lua to run before rendering every single frame. If we did that, we would slow the frame rate of the viewers down considerably, but this way keeps it all in native code and keeps it nice and fast. So a command buffer is this string of commands. What we're going to do is we're going to add one command to this. You can add additional commands to it if you want. You can see there's a few things in here. You can draw renderers and do various other bits and pieces, but the key is the blit. Now, if you remember from our image effect, the blit is it copies a pixel, but does throw through a material. We just pass the material that we provided here, and this tells it to blit on the current camera what we want to do. Finally, the last thing we're just doing is adding it to the space built-in post stack. So you can see with a space, post effects.add command buffer to camera. And you've got two properties here. One of them is optional. The camera event is optional, but the command buffer is not optional. You need to attach one of those. Now, the camera event maps to the same thing that Unity has built in. It's camera event class. You can see if you look at this in Visual Studio, we've got camera events. We've picked 18, which is just before image effects. We could do it after image effects too. In fact, we could do that. 19 is the default, so if you don't specify one, it goes after image effects. You can specify it in things like between transparency renders. You can play around with the depth buffer. You can do it before lighting happens. You've got a lot of power here in terms of how this all gets used and put together. So that's our script. I'm just going to delete our landmark just because I don't want to spawn a player capture. I just want to rely on the camera. I'm going to disable our snowball effect. As you can see here, our images lines have gone off. And I'm just going to save this scene. And with some luck, when pressing play, we will now have our image effect that we've written ourselves attached to the camera. This is the moment of truth, but with a bit of luck. No, it blew up. Might be a small issue. We don't have our main camera, so I might need to do this through the full player chart. All right, flip it off. And if we go DR, okay, main camera with some luck, I do see something going on. Yes, we've got our outline effect, as you can see here. It's a little bit bonkers because we've got a few things here going on, but as you can see, we do have now outlines attached to objects. And I apologize, this is a bit uglier and messier because the Unity built-in post effects and things are interfering with our results here in quite a bad way, actually. Let me try and find that off main camera. I'll just disable those so I get a clearer picture. Right. So let's see outlines on there. So we'll double check that the unnamed command buffer is in fact attached to the object. Pull that off. Something else might be interfering with this, but that should be it. Don't know why that's turned suddenly red, but anyway, answer all your other questions. This is the basics of doing what we've just all done. If you run into problems, run it through the Discord channel. I'm around there, but otherwise I'll be doing my office hours in the assembly region in just a minute. Thank you for watching, and next week we'll be going into underwater and volumetric effects.